Now, thanks to Nicole. Nicole's here. Okay, thank you for solving that problem the other day. Hi, Nisha, you back? You okay? Haven't seen. Okay. All right. So what happened is, um, if you look at the question that we did was something like this, right? You had to cut off each corner, and we assigned that's x, right? And when you assign as x, can you turn down the volume there, maybe? Logan, can you turn down the volume? For the... That should prevent the feedback. Does that feedback? No, no more feedback, right? Okay. All right. So if you cut each corner up, and we find this value, and I don't know what's the length. Can somebody tell me the length of width on this one? 21 and what? 29.7 centimeter, right? And the we says 29.7. Um, and according to Nicole, she says I can subtract 2x on each side because that's going to form a width. And then 21 minus 2x. And the height is it becomes x, and that becomes the value. Right? And she was really smart too. She's like, I'm not going to take a derivative of this. I'm just going to use decimals. Oh, you did. Good job. Okay, so if you did, great, because you're supposed to do it on the test. Okay, you're supposed to do it on the test. You're supposed to take a derivative, set it equal to 0. Now, here's the two things I want you guys to know. I didn't know this until like a couple of years. I was teaching group of 7th grade how to do calculus. One of the 7th grade, his name is Jonathan. Jonathan's dad is a professor in UCF. Okay, so he's a doctorate. And he decided to audit my class. He decided to say, I don't know if I want to hire you. So he come into my class, and he come into my class, and I didn't know who he is. He's like, may I teach some stuff? And I says, I always know, like, never underestimate somebody, never look down on anybody, because most likely they are gonna be smarter than you. In this case, they are, because he's Dr. Ye instead of Dr. Wang instead of Mr. Ye, right? So he went up to the board and he started talking about related rate. And he was talking about changes. He talked about something, and I learned something from him. He says, because he's an engineer perspective, so there is a domain and range in the math, right? But in engineer perspective, for those of you guys who want to become engineer, you have to worry about it's not the actual X and Y domains. You have to actually worry about physical domains. So he really taught me something new when he was go up there on the board, and he started explaining all this crazy stuff he does in UCF. And I was like, well, I also opened my eye a lot. He says physical domain is more important in terms of engineering. And we're going to talk about here, there's a physical domain here. Can you guys tell me where's a physical domain lie? Okay, I'm going to go with Robert, because out of respect to his...
I think the physical domain here is the actual edges of the paper. Like you can't go beyond the actual physical paper, you know?
Okay, what would it be though?
It would be 21 and 29.7.
Well, oh yeah, that's a physical domain. But what X can be?
What X can be? Oh, well, it's gotta be less than both of those.
Or what would it be?
I'm thinking really hard.
I think it really hard.
Half of 21.
Why is a half of 21, Nicole? Since she's the one that contribute, yes.
Because you're minusing 2x from each side, so
But why it's not half of 29.7?
Because 29.7 is bigger than 21.
So why do I take the smallest side?
Because you can't go with the negative.
Okay.
But really, less John.
Okay, so worry about physical domain. So physical domain here. So 21 minus 2x is equal to 0, and 21 equal to 2x, and x equal to 21 over 2, which is roughly 10.5. So x cannot be greater than 10.5, so 0 less than x less than 10.5. This is called a physical domain. Okay, so in engineering perspective, this is a very, very important. X can be anything, yeah, mathematically speaking, right? But physical domain, for example, time cannot be negative. That's another physical domain. So those are something that I think is very, very interesting so far as in terms of math. So why did she take a derivative? Because she take a derivative, she can find out the horizontal tangent. And once she find the horizontal tangent, we're going to look at both derivative. We're going to look at all the things combinations. So here's all the things I want to look in combinations. So we're going to type in the decimal just like her. We want to be lazy. And not that it's bad. I think it's great. So I'm gonna say v of x, right? V of x is equal to what was it? X times what? 21 minus 2x. And then what? 29.7 minus 29.7 minus 2x. Okay, so that's that. Okay, so we have a straight line, great. And we have another straight line, great. So what's wrong with this graph? What can I do to rearrange this to make sure it sense? What? You had to zoom out. Oh, there was 3 lines. Shit. Well, first of all, you had to change the y, right? Y is a volume, right? And yesterday or 2 days ago, we find out highest volume is roughly like 1100 or 1028 to be exact. So I'm gonna change that from y-axis from maybe -4 to maybe 1500, and boom, you got this, right? And what's nice thing about this, because if you click on any part of this graph, right, it's gonna tell you volume at any time. So she says here at the highest is 4.042, which is awesome because she got exactly that value. But the volume is going to be 1128,495. Does that make sense? So that is the highest volume I can ever reach. But the nice thing is, some of you guys probably start thinking, how much should I cut, right? I can cut it really small, but my volume is going to be so small because the box is going to be very, very thin, right? But if I cut it too much, let's say if I cut more, I'm gonna get taller box, but then the base becomes what? Smaller. So this is relevance to everything. Does that make sense? Are we okay here?
What about all that extra? It's like, it goes to infinity, but
What's past 10 and a half?
Good job, Robert.
but it's no longer negative there. That's why.
It doesn't matter because the graph. That's why physical domain is important. Good job, Robert. It's a physical domain is very, very important because yes, what happened to here? Volume go to higher, but the problem is not realistically because that's a passive physical domain. And actually, in chemistry, you learn something, right? Anybody in AP Chem? Yeah. The 21.21 and minus 2x, that's called limited reagent, right? That's the restriction. That's the bottleneck. And that's where the limited reagent comes in. So that's the as much as chemical reaction is based on the limited reagent, not based on the whole, not based on the bigger thing. So limited reagent in physical domain is roughly the same in terms of this cases. Confusing? Okay, so that's why it's here. What if I cut it more? Well, the volume is going to be bigger. That's not true because physical domain is cut it at 10.5, which is what we assume. But what's nice about this graph is I'm going to show you 2 other graphs, and we can talk about all the graph at the same time. This graph, we're going to do v prime of t here. So I'm going to do v prime of x, okay, and then v double prime of x, v double prime of x. Okay, and you got all this crap, right? So I'm gonna unhighlight this. I'm just looking at derivative, right? Now do you start seeing where I'm going with this? Because AP exam always give you the prime graph and ask you to predict, right? So if I were to do number line test, right? If I take this, right, and I say, hey, let's do a number line test, right? A number line test is roughly that it's at, I don't know, 4.032 or something like that. And then this one is gonna be positive, and this one's negative. Guess what? This is a maximum. You start forming connections now. Does that make sense what we talked about before? And this point here, it should be what of the original graph? Let's say, I don't know, what is that? I think a 9 point something, like between 8 to 9. What is that to original graph? For v of x? Huh?
What's the maximum?
No.
Oh wait, where are we looking at?
The point to the red dot.
So this is a v prime of x, right? Now, if you look at the v double prime of x, which is taking the derivative of this, right? So that means what? This is an inflection point because I don't know what the value is. I think that I'm gonna assume that's between 8 to 9. I'm gonna say 8.8 ish. All this is going down, so it's concave down, and this is concave up, right? And this is down, this is up, and this is increasing, this is decreasing. Therefore, this is a max. But also remember, the second derivative test also told you that's max. Why? Because second derivative at this part is negative. Remember, concave down, concave down is like this, right? Therefore, it's the Karate Kid situation, right? If you concave up or concave down, then that's a maximum at that critical point. I'm trying to put all the picture together. Does this make sense?
Yeah.
And then if you have something like this, if concavity is up, then you have a relative min. That's really important because we also talked about second derivative test as opposed to first derivative test. And let's go back to see that's true. Because if we compare all three graphs, go back to original graph here. If you look at here, this is the same coordinate, right? And if you look at here, the 8.45 is where the concavity changed. Do you see that concavity change around at this point? It went to change it to concave down to concave up. So we put all the picture, even a simple optimization question, you can put all the whole, see the whole big picture. And that's big picture is what makes calculus is one of the coolest math subject. I think. You can connect all the picture, the first derivative test, the second derivative test, the optimizations, the physical domains. I mean, I think it's cool. You don't have to do, but I think it's cool. Does that make sense? Okay. So now with optimization, we're going to talk about what kind of problem that you're going to see. You're going to see some type of problem. In this case, this is called a primary equation. This is called a primary. Primary is the one that you take a derivative. Now, if you learn that in last year, probably they also tell you about what is the secondary equations. The secondary equation in this case will be, like say, is 21 minus 2x, and I say 29.7 minus 2x, because that's the length and width, right? That will be the secondary equation. The x is also a secondary equation. You put them all together. So you substitute in to figure out what is the one that you want to take a derivative. Primary is the one that you want to optimize, whether you want to maximize or minimize. So that's the one you want to take a derivative, not the secondary. So now here is what we're going to do is we're going to create a situations. And you've done this question in the past, so now we're going to think about how this question is thinking about. The secondary equation, just like the way I kind of think about secondary equation is like the cone problem. There is a second relationship that you can substitute in to solve to become one variable that you can take a derivative. Instead of taking derivative of two variable, the secondary equation is to help you reduce one variables. So I'm gonna create a situation. I'm gonna say there's a manufacturer. So what some type of company, let's say company ABC. So a box company ABC, right? ABC. We want to try to design an open top box. Open top box. Okay. Have a square base. So this is a keyword, square base. Have a square base or open top box. So that means no top. And surface area of 108 square inches. So what would be the dimension? What dimension? Sorry, what dimension will produce maximum value? Volume, sorry, not value. VOLU. So volume. Okay. So you want to produce the maximum volume here, and how do you do that? Now, why is this section important? Because any type of engineer has to deal with how to conserve the material use and how to maximize the efficiencies. So any type of engineer, you have to think of those. You cannot build an airplane that costs $1 trillion. You have to build an airplane that carry the maximum passengers at the same time at the smallest cost. So you have to minimize the cost and maximize the passengers, because that's maximize the profits that you can sell. You cannot build a plane that's only have one passengers, right? You have to find a fine tune of this. And that's the idea of optimization. That's why I think this is probably the most important section about realistic life than anything else. So how do we create an open dot box with a square base bottom? So it's going to be a square bottom. Yes, Jonathan?
Oh, it's just a square base, not a square box.
Square base. They're not necessarily square top box. Yes, square base.
What I did was I made it like actual square, like cube all around in front of the thing, because to find the surface area, then it would be 5 on each side. There's 5 different surfaces because there's no top surface. So the surface area would be for each little box would be 108 divided by 5. And then from there, if it's a cube box, then I can just square root what I get from 108 divided by 5, and that's the length of 1.
So you're assuming one of the length is 5.
No, I'm assuming that the box is a cube.
You're assuming a box of cube. You cannot assume anything.
Well, if you want to maximize volume, don't you want it to be cube?
It could be. It could be.
I mean, even if it's not a cube, even if it's just a box, if I get
It could be a cube. It could be a thing, but the setup of this equation is a little bit different. So
I would still get 108 divided by 5. It would be the average of all the sides combined.
yeah, but we want to think about calculus right now. So the way I'm gonna approach, yes, Nicole. Nicole, what are you gonna say? Somebody raise their hand on that side. I don't know who.
Yeah. I was gonna say that you want to start with the surface area formula, and you want to get it into a singular variable so you can solve for h.
Okay, but what we're trying to maximize here. Okay, let's start with the value instead of surface area then, because that should be our primary. Okay, so how do I assign variable here if we have a square base? Yes.
You can set length and width equal to each other. So we'll just do like
Good. Good. Width square h. So we're gonna, in this case, we're gonna call, you can call width, so width square h. Does that make sense? Are we okay here? Okay. Now, what is the secondary equation? Secondary equation suppose use other resource, right? So the secondary is revolved with the surface area. So surface area is 108. Does that make sense? But what is 108 equal to in terms of, if this is a width, this is a width, this is a h. If in terms of this, what would they be? What? No, because they are that different height.
W plus W squared.
6 what?
No, not 4, not 6, 4HW plus W squared, right?
Okay, good, good, good. Because there is one base on the bottom, so let's count it up. There's a W square, so that's good. That's W square. Plus what? 4HW. Good. You have a very good visualization, so you see that happening. Now, why is this beneficial? I can reduce a variable here, right? No, there's an open top box. Now, if it's not open top box, then it was 2W square. Now, why is this beneficial? Well, we can solve for h, right? It's nice because this is called a primary, and there is a secondary. Okay. Question about this part. So can I solve for h? H is equal to what? 108 minus W squared over what? 4W. Good. Now, which is nice, you get B equal to W squared times H. H, I may use a different color, so it's going to be what? 108 minus W squared over 4W. So can I simplify this? Yeah, 4W, this one's 27 over W minus W over 4, right? So I'm going to get 27W minus what? W3 over 4. W cubed over 4. So that's a value. What else? Can I take a derivative out here? So V prime is equal to what? 27 minus 3 over 4W squared. So can I set 27 is equal to negative 3 4W, now plus 3 to W squared. So it'll be 108 equal to 3W squared. W squared is equal to 36. W is equal to 6. Can I solve for H? Okay, let's try solve for H. So we can plug in 108 equal to 36 plus 4H6. So B 108 is equal to 36 plus 24H. 72 is equal to 24H. H is equal to what? 3, right? So be 6 times 6 times 3. Is that a cube? You cannot assume it's a cube. You have to assume what is given to you. You cannot assume that's a cube. Because you assume that's a cube, then you're not proving it. Ideally, you probably think it's a cube. I would think too, intuitively. But it's not in this case. Now, if you have a cause involved, that's going to be even more different. So the cost, you want to minimize the cost. You have to optimize the value, but minimize the cost. If it's cost, it's going to be different. Okay. Does that make sense? So first of all, understand what you're trying to maximize. In this case, what we're trying to maximize in terms of this is the volume. The secondary equation is the constraint that they will give you. So that's the material that you can use. And you cannot use more than that. You cannot use more than surface area 108. So that's your secondary. That's the second information. Usually second information deal with the numbers that you can deal with it. Are we okay here? Okay. This is the first kind of situation that you might get. You have homework based on this. Does that make sense or no? Okay, so figure out what you're trying to maximize. Draw the picture, right? We always talk about drawing picture. How important drawing a picture? Because if you draw a correct picture, you know it's W times H. And then you know the surface area is going to be W squared plus 4WH. That makes sense? Okay. So the second things I'm going to talk about is the minimum distance. And this is also another popular one on AP exam, especially on multiple choice. There are two things that we can think about here. So they say which point on the graph y equal to 4 minus x squared are closest to the point 0, 2. Or that's closest to 0, 2. Let's graph that first. The graph of that is going to look like this. I'm going to graph a little bigger so that you can see. The point of interest is 0, 2, so I'm going to mark it 0, 2 here. 0, 2 is right here. I'm using 2 squared is that. And then it's going to be 4, so 2, 3, 4. So 4 is going to be the blue line. And at 2 is going to be intersecting because that's 2 and negative 2. Which point on the graph of y equal to 4 minus x squared are closest to the point 0, 2? In this case, what do you think the closest point will be? Intuitively, what do you think the closest? 0, 2? 0, 4? 0, 4?
Which are going horizontal.
No, it's somewhere in the middle.
Yeah, it's gonna be somewhere in between horizontal and 0, 4.
Okay. What we're trying to minimize here? Distance. Do you know distance formula?
Yeah.
Okay, can you figure out distance formula? I can figure out what's the secondary here.
Just like, no, it's just a Pythagorean theorem, but with like just of this.
Do you guys remember what the distance formula is?
It's Pythagorean theorem.
Something to do with Pythagorean, you're right. Has something to do with square root. It turns out Connor was right. It was somewhere in the middle. Not this one. Visually, you kind of see that visually here, it's a further distance compared to something like here, right? This seems like a little bit shorter than this, right? So somewhere around here, I don't know if it's right here or here, but I feel like this part is longer than this part. That's just me. So I feel somewhere around here. Now from this distance here, so this is the distance I'm talking about. It's from here to here. What will be a distance here? What will be the equation here? What is it?
y2 minus y1 squared plus x2 minus
Okay, so let's do that. 1, 2 minus y1 square plus x2 minus x1 square. But what is the y1 and x1 here? 0 and 2, good. So it'll be y minus 2 squared plus x minus 0 squared, right? Now, do we have a secondary equation here? What?
secondary equation?
Yeah, what's the secondary here? 4 minus x squared, good. So y equal to 4 minus x squared, so it'll be 4 minus x squared minus 2 squared plus x squared. Does that make sense?
Could you zoom back in?
Because I just substitute a y. Y is equal to 4 minus x squared. So can I say that's equal to what? 2 minus x squared squared, good. Plus x squared square root, right? Can I expand that? It was 4 minus what? 4x to the square plus x to the 4th, I think. Yeah. And plus x squared, square root. So it'll be square root of x to the 4th minus 3x squared plus 4. Does that make sense? And that's a distance. Now, what's nice thing is, I'm going to show you a trick to do this. It's much quicker. Since that's a dimensional, we're going to square root anyway. We only care about what's inside. Can I just take it whatever inside and don't worry about square roots? Because if you do square root, require a chain rule, which is much more complex. Can I just think about shortcut? Because we are trying to maximize here anyway. We not care about the square root. Can I just take consideration of this instead of looking at the whole square root? Because whole square root is a distance, but we're trying to maximize inside material anyway. If you maximize inside, yeah, well, yeah, we're gonna take a derivative. We're gonna assume that distance is gonna be the distance is gonna the value I'm trying to maximize is in here. Okay, but that's not a distance. We're gonna call this f of x. Okay, and then we're gonna take a derivative of this. So that's gonna be 4x to the third minus 6x. And then we're gonna set 4x to the third minus 6x is equal to 0. Factor out 2x, right? X minus what? Wait, did I take a derivative? Yeah, I did. What?
Oh, no, never mind.
I get rid of square root is because I don't think I need to do a chain rule. Yeah. Why don't you do a chain rule? I'm trying to maximize inside. Anyway, I'm not trying to maximize with a square root. Whatever insides represent the distance square. So I just take whatever is inside. That kind of confuses a lot of students. I don't care about after square root. Because if I do a chain rule with that, it's going to be much more tedious. If I just do here, I just only have to do power rule because I only try to maximize inside material anyway. I don't can disregard outside. So I'm just building out a function we can call it f of x. And we take a derivative of that. And then I factor out x, I'm going to get x squared minus what? 2x squared minus what? 6? 3. I can't count. So 2x squared minus 3 equal to 0, 2x equal to 0, x equal to 0, x equal 3 over 2 plus minus. Now we want to minimize distance, right? Can I take a second derivative here? Why do I take a second derivative? Let's try it. 4, that's going to be what? 12x squared minus 6, right? What happened if I plug in 0? What happened? I got negative 6. Negative 6 is concave down. Is it maximum or minimum? It's a maximum. Are you trying to maximize the distance? No. So therefore, see the second derivative test come in play, right? This one is equal to negative 6. This actually end up to be a maximum. So we know, we just disproved that at 0 is not a correct value. Now, how about at square root 3 over 2? Well, 12 times square root 3 over 2 squared minus 6, that's equal to 12 minus 3 over 2 minus 6. That's 6. That's 18 minus 6. That's 12. So it's 12 is what? Concave up, right? This is concave up. If it's concave up, that means what? Is the minimum.
Also, in terms of the graph, doesn't it make sense? Because wouldn't there be 2 points that are the minimum distance?
They are 2 points, so that's why they got plus minus. See, here you got plus minus. You can plug in plus minus. You're gonna still gonna get same result. So you have a plus minus square root 3 over 2 is probably right here. And that's going to be the smallest distance from here to here. And that's the coordinate. If you want to find out the y coordinate, you had to plug it back in. So be y, if it depends on which point, right? They say points. So 4 minus square root 3 over 2 square. So that's equal to 4 minus, I think it's 3 over 2. And then that's equal to what? 5 over 2, I think. Does that make sense? So it'll be square root 3 over 2 and 5 over 2. And the negative square root 3 over 2, 5 over 2. So those are the closest point to the graph. How much time I have? 10 minutes. I'll give you one that's similar to this. We're gonna do a pick part pen problem. Shall we? Do you guys think you can do this on your own? Yeah. Okay. So we don't worry about it. Let's deal with pick pen problem. Okay. So the pick pen problem is don't have a pick pen problem here. Is from that just say I don't know what kind of question. Maybe we can look it up. Actually, I want you to do the distance one. I'm gonna leave for you guys to do. If you guys have questions, just go back, look at it, the notes. And this is actually the worksheet we want you to do anyway. So, yeah, this is the worksheet we want you to do anyway. We're not out of question, but we want you to oh, okay, we want you to do question 5. This has something to do with the first one. So question 5. You guys can help out each other. assign variables here will help you. Yeah,
Are the two squares supposed to be equal to each other, like the area of the two enclosures?
they're not necessary squares.
Oh yeah, I'm talking about like the enclosures.
They're next to each other, yeah. So you
No,
don't.
but are they equal to each other? The areas. Do we know this? If it is or not?
This is suppose you have 1 or 2 fence makes 2 side by sides enclosure. So what is the maximum area you can enclose? That's it.
You have three. Why would you minimize the height? Okay. I think that would really maximize area.
You basically just want to get it into the group, but with the area formula with one variable. So I would solve for the, I think you could also just solve for like, yeah, and then
Okay, well,
probably the second variable.
talk theoretical back end.
Where's the maximum area? Yeah.
Yeah, I kind of did my stuff for it. But like we have to get it down on one variable.
Secondary, usually the one will deal with numbers. Because with the number can assist you to reduce one variable.
Yeah, I think primary and then. So then that's primary. Or since we have this number, then it would be 3y plus. I don't know if I should make this entire width. I feel like I should.
So you plug that back in. And then
What's the area?
oh, for the group.
That's bad.
I'll give you an answer. The maximized area is going to be 433.5.
We're trying. Are you sure?
What?
We're trying.
Okay.
What's the limit? So then, you know, height rate.
Are you sure that I got pointed that.
According to the answer is 433.5 square meter. I'm pretty sure it's correct because I've done this worksheet before. This is a very popular worksheet.
Over 2 minus 39 over 2. So 51 minus 39 minus 2 W. Oh, that's why we're thinking.
Bobby, shut up.
So the area of
but we don't know. We don't know that like length and width are just not squares. So actually, like we know, it's just how we know. It's just you know what I mean?
That's it. That's
What? Wait,
so for why?
We have.
wait, did you guys want to?
433.5.
We would be fine.
Oh, good. You're gonna guide your table though.
Simplify the equation. And then you also change rules in five.
How do I take up?
Yeah.
We got one student got it so far. Luke got it too, right?
Yeah.
Okay, Luke and Nisha got it. Yes.
I'm trying to figure it out, but I don't want to get.
I'll give you a hint. Draw. Well, there is two ways to do it. You can do the whole thing is a W, or you can do 2W, 2W.
That's what I've been.
So W, 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 L, L, L.
Yeah, that's what we've been doing.
Okay, so it's W, 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 L, L, L.
Yeah.
Then,
The area is what?
what will be the area?
Would it be four W?
Oh, it's a 4W. It's a rectangle. If you have W, 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 L, 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 then what will be the area of the rectangle? 2W, good. How about the secondary? Well, how do you get 102? Secondary is your 102. Well, it's not really perimeter because there's a. So the way I would do it very quickly, I'll just let you guys do the math, but I'm gonna set up the equation. The way I'll kind of do it is I have two things right here, right? And this is W, 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 W. Some people use 2W, or just W on the top, but I use L, L, L here, so it'll be the area is gonna be 2WL. That's a primary equation. The 102 is equal to 4W plus 3L. And then you solve for L or solve for W, substitute back in, take a derivative, and you're done. So that was the hard part. 433.5. The maximum area. So the hard part is set up the equation, not a derivative. I know you guys can take a derivative, but the equation is hard. Yes. What? No, probably next Tuesday.
We only have one. This is like our first real day.
Yeah, but you guys on BC Cal, you've done this before. You've done with Cooper. You've done with Craig.
A year ago.
Oh my gosh.
I just did. I was wrong with my.
But you got 25.5.
For the length, and then we saw the area.
Right. Yeah.
So I didn't length with
Yeah. Oh, so it was good.
here. I did wrong with like can't multiply. Yeah, I feel like I'm really good at calculus. I just can't do the rest of it.
You cannot do algebra.
I can do multiplication.
Multiplication, addition, and subtraction.
Fuck you, I'm not answering that.
Yeah, she still doesn't know which quadrant is.